Hey y'all, it's Andrew Couch here, and in this Tidy Tuesday video, I'm actually not going to work on this week's dataset. Instead, I'm actually going to focus on feature engineering with the recipes package. So when I was looking at the recipes package, I actually saw that they had like an ordering of steps article, which kind of shows you a little checklist of how to actually use the recipes package in a specific workflow. So I thought it'd be fun to kind of go through this checklist and use the famous Titanic dataset. And for the Titanic dataset, each row basically represents a passenger on the Titanic and whether they survived it or not. So it's a great predictive modeling problem, and you can learn a lot. In fact, the first time I was actually using R, the Titanic dataset was the first dataset I was actually analyzing. And I was actually doing that in base R, so that was a lot of fun. So we're actually going to load up a R markdown file. Let's see here, from template, GitHub document. I'll call this the Tidy Tuesday Titanic. Okay, cool. So we're gonna load in the tidyverse, the TidyModels package, and our data set. So df read.csv, titanic.csv. Okay. So first, let's just do a basic summary of it. And we can see that we have 1, 2, 3, 4, 5, 6, 7, 8 columns. We can see our survived column, which we're trying to predict, and it appears to be a binary variable of zeros and ones. 1, I'm going to assume, is that they survived, and 0 if they did not. Additionally, we have 7 other columns. We have, I guess, P class, name, sex, age. Cool. So when actually looking at some data sets for predictive modeling, it's pretty important to look at the data quality issues. So the biggest thing is just seeing how many NAs or missing values there are. And this summary function kind of shows each column or each feature's total NAs. And that's pretty helpful, because if you are looking at your data set and you notice, say, one feature is missing half its values, it's worth considering actually dropping the entire feature. Additionally, one other thing we should look at is, I guess, row-wise total NAs. So if a sample is missing, say, half of its features, it's worth considering also dropping that sample and not using that in your data, in your modeling or analysis. Additionally, if you see that, say, a lot of NAs are centered around a certain feature, say, for example, high fares have more NAs than low fares, it might be worth considering why that's happening. For me, I actually know that these NAs are random because I went into the data set and randomly removed some values, but we're actually going to find out, say, the row-wise total count of NAs. Okay, so I actually don't really know an elegant solution to finding out, I guess, the row-wise counts. I know there's a row-wise function, but I'm not really sure what that does. So maybe if I look at that, row-wise do, so there's something, it's paired with a do, so it's some type of, like, I guess, like mapping style thing. But I know one way I would do this, basically. So I would probably just make essentially a row key. In this case, we could use name, but sometimes we might not have a unique classifier. So that's what we're gonna do. We're gonna say mutate, and we'll say row key equals row number, right? And then what I would do is I would do a gather, so key equals key value equals value, and then minus row key. Okay, so now we have that. And then finally, I would say filter value value is .na, and then I would just count the row key. And then maybe say like a sort equals true. Right, so right here, we're just counting the missing values in each row. And we can see that, okay, the most amount of missing features is 2. I'm comfortable with that, even though there's only about 1, 2, 3, 4, 5, 6. So 1/3 of the total features are missing at max, and that's only with 2 of the samples. I'm fine with that. I would say that it's definitely dependent on the person, the amount of features you have, right? So we're gonna just deal with that, and let's look at the actual recipes steps. So the first thing I should do is do any imputations. Okay. So we're going to do that. Okay. First I'm going to say row wise counts of NAs. Okay. So we're going to do a summary again. And let's first focus on P class. Okay. So if we look at P class, let's just do some summary statistics of it. So we can do that. We can do let's see here, group by P class, and let's say summarize count equals N, average age equals mean age, and say, I guess, NA dot RM equals true, average fair equals mean fair, NA dot RM equals true. Okay, so what we can see here. Okay, so we're missing 4 P classes, and in this case I think it's payment class, because we can see here with the average fare that the first class people are paying a much higher fare. Third class people are paying less fare. Middle class or second class are paying, you know, a little bit over the a lower third class fare. Additionally, what we can see is kind of the basic counts of each class. So we can see that, oh, the majority of people were in the third class, then in first class, and then in second class. Okay, so there's kind of a dispersion right there. We can also see the age is kind of centered around 25 to 38. There's not a huge age difference between the third and second class. However, the first class people are a little bit older. We can also look at our NAs and see that, okay, for our average NA age, it's actually was it 39, so they're much older. However, they have a much lower fare. So that could mean a few things. On one hand, it could mean that there's a person in this sample that has a much higher age or who's much older. And it also could mean that one person has a much lower fare. So let's look at that. So let's say filter P class is.NA. Okay, and let's look at that. We can see the fare is centered around what I would say is the second. I guess it's centered around a little bit, but all of them. So this person, Mr. Francis Davis, is probably maybe a upper second class person, but the majority of these people are probably in the third class, right? Additionally, we can see how this guy is much older, and also that he's paying more. So if you're older and paying more, I would say you probably fit in the first class. However, these young people who are paying way less, I guess this young person who's paying less, and these people are paying much less, I would definitely tell them that they are probably in the third class. So these type of not necessarily hard combinations, but it's something where you kind of are comparing the similarities, and it appears to be meeting some type of pattern. We can impute this using the KNN imputation algorithm, and they actually have this thing called step KNN impute. We could do a mean, median, or mode, but since we see that there's other things that kind of are these small indicators that we think are intuitive, we can actually use kind of a machine learning algorithm to actually do the imputations, which should be a little bit more robust estimate. But if you want to be safe, you can do a median. So that's what we're going to do. We're going to do the step KNN impute. Okay, so we're going to say step KNN impute. And I'm actually going to do some data cleaning first. So first we should do, but first we need to clean. So if we look at our data set, one thing we don't need is we don't need the name. Okay, the name can basically act as a primary key, so we don't want that. Okay, additionally, what we should do is we should mutate sex is equal to as.factor sex, and also survived is equal to as.factor survived. Okay, so we have that. We have P class, which is int. I think a payment class can definitely be served as a factor. So we'll say P class equals as.factor P class. Okay, so we have 3 factors, and the rest of these guys I would say are these like continuous variables, so we don't have to worry about that. Okay, so we got that. Now let's define our recipe. So recipe, and in this case, what we're trying to do is we're trying to predict survived. So let's say survived data equals df. For this example, we're actually not going to do any modeling right now. We're actually going to focus most on the feature engineering. So what we're doing basically is using the entire data set, which will cause leakage if you want to use this in the modeling. However, it is very simple. We could just do a training and testing split and then just use the training data. But since we want to see kind of this like tactile feedback, we're just going to apply it to the entire data set to get some type of intuition and also figure out what it's doing. Okay, so we'll say, what's this called? Titanic Wreck. Boom. So Titanic Wreck, we can look at that. Looks good. Okay, so with Titanic Wreck, we can do the imputation. So step, was it knn impute, and we want to impute this to the P class, right? So it's doing that. It's applying the K nearest neighbor imputation for P class. Cool. Okay, so next what we need to do is, since we finished P class, what we should start looking at, let's see here. What we should start looking at is the number of sex, the sex, okay? So in this case, if we do count sex, we can see that there's 5 missing values. The majority of the sex is male. Okay, so that's pretty interesting. One thing that we should do is we should just do a group by sex, and maybe do just a summarize and say, like just maybe do an average age equals mean age, average fair equals mean fair. So we're gonna do that. We can see the na.rm equals true. na.rm equals true. Okay, cool. So we got that. What is our missing value showing us? Well, our missing values appears to be on average older and on average has less money. That is a strong indication of male. So let's look at that. Let's say df filter sex is.na. Okay. So we got that. They're definitely older. They're paying more money. One person has a sibling. First, and then two of the 5 survived. Cool. So for me, when I'm looking at this, I'm not really certain on how it's gonna work. Additionally, since this is a factor or categorical variable, we can't use median or mean. So one way that we can do this is we can do a modal imputation. So we're just gonna impute the most common value. So that's what we're gonna do. So I'm gonna say impute the modal categorical value. So I'll say Titanic Wreck step mode impute, and we're gonna apply this to sex. Very cool. Cool. So we have that. We can do another summary just to see what else we need to do. Okay, so now we're gonna do sibling and parent. Oh, we can do age. Okay, let's do age too. Okay, so with age, I'm not even gonna look at the actual crosstabs. I'm gonna just do a simple plot. So let's do the plot: age plus geom density. So when I'm looking at this, we see that age is definitely centered around this big hump right here, which begs the question, like, should we do kind of like a mean or a median? So let's look at that. If we look at our ages, we can see the difference is between basically 1.5 years. Okay. Since we're doing age, I'm just gonna do median. I think when I think of age, I always think median value. So that's what we're gonna do. We're gonna say impute using median age. Okay, so Titanic Wreck step median impute age. Right? Yeah, let's do it. Cool. So we have that. Now what we're gonna do is sibling and spouses. So I'm just going to copy this, and that's a lot of text. Okay, so we're going to do df select these guys. And one thing that I was looking at is, okay, so parents and children aboard. Let's just do some, let's just do a basic plot. So let's do gather, and maybe just do a ggplot. So ggplot, as x equals value, color equals key plus geom, what could we do here? Geom histogram plus facet wrap by key scales equals free. Okay, so we're gonna do that. Cool. So let's see here. Most of the time it's centered around 0. However, for siblings and spouses, it also has a little hump at 1, this little point at 1. And just intuitive, that kind of makes sense because, okay, if you have a spouse on board, they're probably gonna, the spouse is also gonna be counted, and they're gonna say they have a spouse on board. Okay. Whereas if you have a parent on board, you might just only have like a mom on board or a dad on board, and you're probably not gonna have, you might not have more than 1 children. So that makes sense. I guess like the parent and children thing, a child could be counted, and they could say they have a parent. However, it appears that there's way less children, maybe in general, whereas there's probably more likely to be spouses when traveling on the Titanic. Okay. So what does that mean? Well, we can do a lot of things. If we look at this, we can say, okay, on one hand, we could do a, we can look at the summary statistics and we see, okay, most time it's 0. So we could do a mean, a median, which would be 0, or we could do a mean. In this case, I think the smartest way to do it, since you really can't have half a sibling, half a parent on board, I think we should still do mode. So we're gonna do that. We're gonna say, since you cannot have a half a parent or sibling aboard, let's impute with mode. Obviously you could just do median and mean, but we're kind of just going to do this as just as simple as possible. So we're going to impute using mode. Okay, so Titanic Wreck, step mode impute, and we're going to say siblings, parents, children aboard. Cool. Okay. Cool. So we have that. And lastly, we'll do fair. Okay, df, we'll just do ggplot, as x equal fair plus geom density. Okay, and then maybe I'll do a plus scale, x log 10. Just a log 10, so it's increments of 10, of like logarithm of 10. So when you see there's 3 humps, and that's kind of interesting. When I'm looking at this, I'm thinking, oh, I bet this represents like the 3 classes, right? So let's do that. Let's see what that is. Fill equals p class. Yeah, and that's what we're kind of getting. Maybe I'll do color equals p class. Yeah, color equals p class. So what are we seeing here? On one hand, we can see, okay, well, our fair is definitely kind of centered around the 3rd class, and we have all these other classes. So it could be like a 3rd or 2nd class. So let's look at the actual densities without it again, and we look at that. Okay, so let's look at let's look at the summary statistics. So select fair, and we'll do a summary. And we see, okay, median, mean. For me, since I think it's in between 1st and 2nd class, and we can see that our 2nd classes, 1st, 2nd, and 3rd class fairs are kind of in between each other. So 13 and 20. I think, let's see here, 13 and 20. Actually, I'm going to do a MinFair. So MinFair equals MinFair na.rm equals true. Let's see what that looks like. So the MinFair 3rd class, 13, 25, 20. Okay. 13, 25. I'm going to say, since the MinFair, I'll say filter fair does not equal 0. Just to get an idea what the MinFair was looking at. Second class 4. Okay, so third. Okay. So I'm going to do the median. I feel very comfortable with the median. So we'll say impute fair with the median value. Strong suspicion that it is third or second class. Actually, what third or second class? So if we do let's just do another filter then. Filter fair is second class. So it's second class. That means what we can do is we can do the actual mean. Okay. Actually, instead stretch that, impute using mean since the P class is second class. Okay, so we're going to impute using the mean. So Titanic Wreck step mean impute fair. Cool. So we did that. We finished with that recipe. So let's go back. Ordering the steps, we got done with the imputation. We can do individual transformations for skewness. So let's see if any of these values are highly skewed that we feel that might raise some complications. Okay, so if we look at our summary, we can yeah, there we go. Sorry. We can notice that our minimum value does not go below 0. So if you look at this, if using Box-Cox transformation, don't center the data first or do any operations that might make the data non-positive. Alternatively, use the Yeo-Johnson so you don't have to worry about this. So when I'm looking at this, we can use center scale, Yeo-Johnson, or Box-Cox. For me, I just use Box-Cox because I kind of like it, especially if we don't have non-negative numbers. So we can keep that in our heads. This is mostly for individual transformations, so that's what we're going to do. We're going to say select if is dot factor select that var how do I say not is that no vars select at is dot vars is dot fact. Oh god. Okay, well, we're not gonna do that. So select at is dot fact. Select if. How do I do the let's see here. Select if. Let's see here. Select if not tidyverse. Let's see. I'm trying to think. How did I do this again? Oh well, we're not gonna worry about that. So we're gonna do df select minus survived minus p class minus sex. Maybe do throw in a gather, and then just do a ggplot as x equals value fill equals key plus geom histogram plus facet wrap by key scales equals free. So how do I select non-numeric? Select if negate. Oh, okay. So I do select if negate is dot factor. Cool. That was really easy. Okay, cool. So we can see that age, it's showing kind of like a normal-ish distribution. We can see how these guys are not. It's mostly centered around the left. I don't know the exact name of that distribution. Maybe it's exponential or something like that. I don't know. One thing that I was thinking of, maybe we could do like a scale x log 10 and see if that does anything. And that doesn't want to change anything too much, so we're just doing that. Okay, so we kind of look at it. No distributions are super concerning. So I'm gonna kind of check this off and say, okay, we can keep on going on to the next list, which is discretize. Discretize is essentially binning. So say if we see fair, we can essentially make the payment class. So we could say, oh, like fair between 0 and 100 is non upper class. $100 and above is upper class. We don't really need to worry about that right now. So we're gonna go on to the next one, which is to create the dummy variables. Okay, so we know we have factors. So we're gonna say finished imputing. Now let's put in some dummy vars. Okay, so if we do df, we know we have 3 different factors. However, we're trying to predict survived, so we only have to convert p class and sex into dummy variables. So that's what we're gonna do. Let's see here, Titanic Wreck, step dummy, and then we'll just do p class and sex. In this case, I'm not actually gonna do any one-hot encoding, so I'm just gonna do the simple dummy var. So we're gonna look at that. We have the dummy var, and we're gonna do that. So cool. We got finished with the dummy var. What's next? So we can create interactions. In this case, I don't feel comfortable making any interactions. There could be an interaction between, say, your sibling and fair. I'm not sure, but that's something where you'd have to do a bigger EDA. And I think I don't want to make this video too long. So we're going to go to the next step, which is these global normalization steps. Okay, so normalization. So most models actually benefit from some type of standardization or normalization. I honestly don't know of a model that gets actually hurt by normalization. One thing that I would maybe think about is maybe normalization might hurt, say, like a Stan model, which really wants to preserve these specific distributions, but I don't have a deep understanding of that. So I would say a good rule of thumb is always normalize. It certainly can't hurt you. And if you know when to not normalize, then you're probably out of the scope of this class or out of this video. So we're gonna start normalization. If we go to the function references, we can see that there's actually a decent amount. Let's see here, decent amount of normalizations. So there's step center, step normalize, which does the center and scaling. We can do step range, step scale. So we can kind of decide, on one hand, we could do a Box-Cox transformation, which I actually enjoy doing. We'd also do, say, a Yeo-Johnson. But I think the default thing that you could do if you don't really know what to do, or if you kind of just don't want to look at anything, I think the step normalize is the best. And this applies both as center and scaling. So that's what we can do. Titanic Wreck and step normalize, and I would believe what is that, all and we would just do this all numeric. I think all numeric is the go-to one. Let me check that. Let's see if my internet's slow. Why is my internet so low? Okay, I think it's all numeric. Let's see what that does. Step centering for all numeric doesn't. Oh, okay, so all numeric. I'm gonna keep it. Let's see what happens. So step normalize all numeric. We applied it. I don't know why this thing is weird. So we did that. We finished step 6, and now we're on step 7, which is multivariate transformations. Always, I'm not very familiar with a lot of these, but I've seen, say, like obviously like PCA. I've seen spatial sign preprocessing. So a lot of these things you could definitely do a huge thing into it. It definitely goes with, say, like it's kind of like distances between each columns and on the relative on the samples. And it's something that could be done, I guess, as like kind of a feature reduction. There's also other things like, say, removing highly correlated values, which is definitely necessary, say, in like linear regression for like multicollinearity. There's also NZV, or near zero variance, and zero variance, which it basically says that if a value doesn't change, so it's like if the value just stays for the entire data set, we'll just remove it because it's redundant. And you can give it wiggle room for the near zero variance. Then there's also these row operations. Like you can do filtering, you can do lag features, you can do, I guess, shuffling, you can do sampling, like downsampling and upsampling. You can also do, I guess, add an intercept column, window functions, and stuff like that. But we don't need to do that. So we're going to do finally prep and bake the recipe. So let's say Titanic prep Titanic Wreck. Data should be character or factor to compute the mode. Oh, what the? Titanic Wreck. Let's see here. Am I supposed to change? Why is it saying? What? Data should be character or factor to compute the mode. Let's see here. Step center, so let's see here. Very odd. Let me look this up. Recipe. Okay, I'm gonna stop this video and see what's going on. Sorry about that. I was running into some errors with the was it with the siblings abroad and the parents abroad. With the Modal Imputation, I guess it requires a character. So we're just gonna ignore that and just kind of let it ride. Okay, so instead of using a modal impute, we're just gonna do the median impute. So we're gonna just do siblings dot spouses dot aboard and parents dot children dot aboard. Okay, and we're gonna put that into a prep. So we're gonna throw in the prep. Oops. So instead, I'm just gonna do I'm gonna show the entire thing. So Titanic prep. Okay, and then finally, what we're gonna do is we're gonna bake it or apply the actual pre-processing function to the data set. So we're gonna bake it and say Titanic prep with the df. What do we see here? So first we can see the age is centered, scaled, siblings, parents fair, survived, sweet. Okay, so I think that's what we needed. So 1, 2, 3, 4, 5, and then 6, and then that's our 7. We also can do a summary statistics, see if we are missing anything. We are not missing. So survive is still missing one, and that is something where we can actually drop the NA for that. So that's what we're gonna do. We're gonna say processed df bake, and then we'll do process df, and we'll say drop any of the remaining NAs, and boom. Okay, so then we have our process df, and we can finally use it for actual modeling and stuff like that. With the TidyModels, you actually won't see it, but you'll this is kind of a video to show the actual kind of like inner workings and how it works. So I know this is a pretty quick video, but I wanted to kind of demystify the recipes package. I'm still learning about it. I still think there is probably a way to circumvent the modal imputation for the siblings and spouses abroad, but it's pretty easy to just throw in a median instead of a mode. So I'll see you guys next week and tidy on.